First one, to remind you what we did yesterday. The tangent of the arc cosine of 4/7. What did I tell you? Every time you see an inverse or arc in parentheses, what does that allow you to do? Okay, let's do it. Make a triangle. You did really well. Very good. This is make a triangle. Okay? So if we make a triangle, we're taking a ratio of 4/7. And to complete this, 49 minus 16 is square root of 33. Does that sound about right? So now we change this ratio into an angle, essentially a triangle. Now take the tangent of this angle theta. What do you get? Square root of 33, opposite over adjacent. Remember that? Okay, zip down to number 3. Try that one. For this second one, you have arc tangent in parentheses. Make a triangle. Got it? And so then when we make that triangle, we're going to represent it in the SOHCAHTOA fashion of tangent, 3/2. So that's going to be 9 and 4, which is the square root of 13. So what is the sine? What's the sine of theta? 3 over square root of 13. Cosecant is 1 over sine, so what will the cosecant be? There you go. Great. So those go pretty well. And then you get to one like number 2 or number 4. So I'm gonna start with 2 because 2 is kind of a straight shooter challenging problem. What you have here is an arc in the parentheses and another arc in the parentheses. We're going to make, we have 2 arcs. How many triangles are we going to have? 2 triangles. 2 angles, 2 triangles. So the first one we're going to call A, and the second one we're going to call B. And sometimes they give you quadrants, but for now, let's just stay in quadrant 1. So cosine is 2/3, sine is 1/2. So this will be 9 minus 4 is the square root of 5, and this one will be square root of 5, right? That's cool. Next.
Which is the maximum is at E.
Yep. Yep. So what will happen here is that this becomes A, this becomes B. Tell me about, do we have a formula of sine of A plus B? Do we have one of those? Yes, yes we do. C times co, this is plus, this will be plus, co times C. It's going to be big. I hope you have space. So C, the first one, A, is cosine 2/3. Not cosine 2/3. Try that again. Arc cosine of 2/3. First one is arc cosine of 2/3. And the second one is B, which is the arc sine of 1/2. Arc sine of 1/2. How are you ever going to evaluate this? We don't have any way of doing that. Or do we? What do you think? There you go. Make a triangle. Yep. So here we go. Well, we already have it right here. Excuse me, right here. This is 2/3. So the sine of this first triangle is square root of 5. I'm going to write it down below here. Square root of 5 all over 3 times the cosine of B. Cosine is square root of 5 all over 2. Did I do something wrong? Square root of 3, yeah. Thank you. Square root of 3. And then it'll be plus cosine arc cosine of 2/3 is just going to be 2/3, but you can see it's 2/3. And then the arc, the sine of the arc sine of 1/2 is 1/2. So I get for an answer there square root of 15 plus 2 over 6. How many got that? Square root of 15 plus 2 over 6. Questions? Number 4. Turn to your neighbor real quick. Tell them what basic formula we're going to use. This number 2, we use COCO-CC. What's the basic formula you're going to use in number 4? Turn to your neighbor. Tell them. 5 seconds. Go. What's the basic formula you're going to use? Sine what? What do you see? Sine 2a, right? So this is the 2 times the sine of the arc cotangent of 4/3 times the cosine of the arc cotangent of 4/3. Everything good with that? It's 2 sine theta. Is that all right? 2, I'm going to highlight this. 2 sine cosine gives you sine 2 theta. And here's your theta. And we can evaluate these by making a triangle again. We'll call this A. Cotangent is 4/3. So tangent being 4/3 would be opposite over adjacent. So what's cotangent? Adjacent over opposite, right? And that'll be a 5. So this is going to be 2 times the sine. Sine is going to be 3/5. The cosine is going to be 4/5. So I'm just going to get 24/25. Doing okay? All right. Make sure you can do those. You'll see one of those for sure on Tuesday's test. All right, here you go. See if you can express this in terms of r cosine theta minus alpha. Start at a problem like this. They're asking you essentially to find the amplitude and the horizontal shift is what you're trying to find. But to do that, you're going to back up a little bit and you're going to say r cosine, what is r cosine theta minus alpha? I mean, what is it? Well, it's r times co plus c. That's the place to start. Because then what we can do is take this guy here, and then we can align it down below here. So I'm going to put the cosine theta times 4 plus the sine theta times 3. So maybe, well, there's only one answer, but you could write it 3 ways and be correct. So what we're matching up here is that these are equal to each other. And there's a little problem with saying cosine alpha is equal to 4. What's the problem with that? It's not the domain. It's not between -1 and 1. Same thing with sine of alpha. That's equal to 3. That's not in the domain either. So we need to find a way to get it in the domain. And since we're in quadrant 1, no problem. We can make a triangle. And we can say, all right, for alpha, where does the 4 go on the triangle? Opposite, adjacent, or hypotenuse? Where does the 4 go? adjacent. Where does the 3 go? And so what will have to be up here? 5. There's your triangle. Now, why did I do that? Well, if I write this as the cosine of alpha being 4/5, why is that a good thing? It's the domain now between -1 and 1. And then the sine of alpha equal to 3/5. Now that's going to be in the domain. Does that help? Okay, now let's even have it make more sense. Take each of these, make this in a radius of 1, divide by 5, and now you can see instantly that the cosine is alpha is 4/5 and the sine of alpha is 3/5. Does that help? Okay, so wait a minute. Wait. So if that's what it has to be, I only have a 4. So what am I going to do to make this in the domain? I'm going to change this to 4 what? Fifths. And change this to 3/5. So I'm multiplying everything arbitrarily by 1/5. You can't do that. That's against laws of Minnesota. So what do you have to multiply out in front? 5. There's your R. And then for alpha, you can do a couple things. You can say arc or inverse cosine of 4/5. And I would totally accept arc sine of 3/5. Now, if you're fancy pants, what's another one I'd accept? Arc tangent of 3/4, yeah. All of those are correct. I give you any of those, I'd give correct. How are we doing? All right. So overview, what you did is you said, all right, change this to CoCo-CC. We did get a match with this one. We did. We had to get cosine alpha equal to something in the domain. So we made a triangle, put the 4 in the adjacent, 3 in the opposite, completed the triangle. And therefore, to get cosine alpha, cosine sine alpha, you had to have that between 1 and -1. And so what we did is we just divided by 5 because that's the radius of the circle or the hypotenuse of the triangle. And so when I changed those to 4/5 and 3/5, I had to multiply by 5 so that it's still equal to this original amount. So for part A, the answer is R equal to 5 and alpha equal to any of those two. Inverse or arc 4/5, cosine or inverse or arc sine of 3/5. Now it says, write down the value of theta for which f of theta takes its maximum value. I love this question. And so remember we had the 5 cosine of theta minus arc sine, I'll go sine of 3/5. Okay, now it says, hence or otherwise, write down the value of theta that's going to give us the maximum value. So what's the cosine of 0? 1. So it starts up like this, right? So where does the maximum value happen at? 0, right? So what do you want this equal to? What do you want it equal to? To get the maximum? 0. Right? Because the cosine of 0 is 1, and 1 times 5 is 5. That'll be your maximum. And then it says, write down the value of theta. They're not saying the max value, because we know the max value is going to be what? Max value, the biggest number it'll ever get is 5 times 1, right?
Yeah.
Okay. But the theta to get there, the first one, the easy one, is going to be theta equal to what? Not theta equal to 0. Yes, arc sine of 3/5, or you can say arc cosine of 4/5. This, to make this 0, this has to equal arc sine. And those are two problems, sets of problems using inverse.